Welcome back to another Code With Me video. Today we're just going to go through OpenCV stuff. So I'm going to be doing all this in Python, but it translates directly from Python to Java. So I'm just going to look at some of these images, show you guys this. Um, Really, we got an image of Into the Deep. That is mainly what I was using when I made this. I'll just show all these real quick, and then I'll show how they all work. So what we're going to do is I'm just going to run main.py, and we're just going to see a grayscale image. So for this one, all it's going to do is we take the image and we just convert it. So this is going to be the exact same kind of language in Java. We just convert it. We convert the image to grayscale. That's really all it is. It's very simple. We're just converting it all to gray. And all this is going to be on FTC's page as well. Anywhere you look online, it will be there. So this is another image format, YCRCB. So this one's kind of useful because it's really good at identifying blues and reds. So, I mean, that's really good for FTC because for FTC, it's always blues and reds. And it works perfectly. Now, we're going to see an HLS. Really, no one uses the HLS color scheme. It doesn't do much. It's really good at identifying some of these, but overall, and if I could show you the actual image, that would be nice too, but I can't. Let's actually open this a different way because it will look better if we can actually see this. Oh, there we go. Okay. So this is what the base image looks like. And then all these color schemes that we're making are just differences, and it's going to be different for every use case. So you can do half of it as HLS, half of it as YCRCB. It's just going to matter how you design the system. The next one up, we're just going to see an HSV, which HSV is really nice because, as you can see, these blues are completely different. So we have completely different colors. We can really easily identify blues. Can't as easily identify any other color. However, it's nice because the blues become really prominent. And then the problem is with this is that all the reds kind of mix, and the HSV color scheme has red on both sides of the color scheme. So you have to do a threshold from both sides, which is not the easiest thing to do. However, you can do it. It's not all that difficult. So, and again, this will all be online, so it's really easy to figure out, really easy to see, because you can see it exactly as it's happening. Next up, we have a lab color space. This doesn't do much, honestly. Not many people use it. It would be good for reds, because we can see that the reds turn a little bit more yellow. The blues turn green. Could be helpful for that, but I really don't use it. I really just use YCRCB and HSV. So next up, we're going to pull up a submat. So basically what we do here is we're going to grab a submat, which really it's just, okay, we have a bounding box, and we're just going to take this part of the bounding box. So as you can see, we're taking exactly this little chunk out of the image, and we're just saying, okay, yeah, only show me that chunk. So now, if we show a practical example of this, I'll just overlay this. It's going to show, in each of these boxes right here, we're just going to show the average color of each of those boxes. So this one's a little bit more blue, a little bit more dark. This one's more brown. This one's a little bit lighter brown because we got those yellows and oranges in there. And this one's almost purely white. So if we go to the next one, now we're going to get into a little bit more of the complicated stuff. So thresholding. So we're going to take a threshold, and we're just going to say, okay, yeah, take the image, and now I want to see where all the blues are. So we can see, all right, we got all the blue little images here. If we actually look at what this looks like, we take an upper and a lower, And then we just say, okay, is it in range? And then we take a bitwise AND operator with that mask. And basically we just say, okay, we're going to put black wherever this is not blue. And then once we show it, it'll show this right here. Now if we go to the next one, you can see it gets a little bit more, what's the word? It gets a little bit more shaky with different colors because it's harder to tune. Light affects it super heavily, and it's not the best for yellow especially, just because there's a lot of things that you realize are almost yellow but not quite yellow. So let's see, we should have a red. Yeah, there we go, a red. And you can see there's a bunch of little dots around. It's like, I mean, it's not the best. We have where our red pieces are. We know where those are. It works, but the thresholding here, you'd have to say, okay, I want to get the area of each of these, and then filter them out and say, okay, I don't want any of these tiny ones. Alright, and now if we take the contours, basically what this is doing is it does that same thing as we did before with the thresholding, but now we actually say, okay, now I want the edges. So we actually scope out the contours of the edges, and then what we're doing here in this specific example, because this is the max red, we highlight the maximum area as blue. So you can see the B is significantly bigger than the T, especially bigger than the H because the H has the bar in the middle. Yeah, that one's pretty simple to understand, but we just take the biggest one and we say, okay, yeah, we want to highlight that one blue instead of green. So fairly simple example there. This next one is going to be a nice little example of what we did before with the bounding boxes in the actual image. And now we have, okay, in each of these green boxes, what's the average color? So we found that it's red, yellow, blue. Makes a lot of sense because each of these boxes is that color. Moving on to the next one, this is a threshold, and for this one specifically, we're thresholding on this image, and we're saying, okay, we want yellows and reds. So you can see that some of these little areas where it's a little bit darker, or in this case, it's a little bit darker, a little bit lighter up here, it becomes a little bit shakier. So there's a lot you have to do for cameras to get it tuned perfectly. And honestly, it's probably never going to be perfect, but if you can get it close enough and detecting correctly most of the time, you should be fine. I tend to use more of the 3-box method with the submats and actually figuring out what the color is, because that is much easier, much faster, and it's way less time intensive. So it's way easier to tune as well, because we can say that, oh yeah, if our average area here is around these two values, well, yeah, it's red. We can say, yeah, if this box is around these colors, yeah, it's yellow. So it's a little bit easier because we have a larger array of data, and one or two little pieces aren't just going to screw us up. You can see here, blue is usually easier to detect. Yellow is the same here. I didn't use different code because I didn't feel like actually doing different code for the blue and yellow one. I just did an OR. So a bitwise OR operator just basically says, okay, I want to combine this one and I want to combine this one. So these were both two separate submats, and then I combined the two. Next, we're going to just draw out the bounding boxes. So this is for the first one with the red and yellow. We can draw out pretty nice bounding boxes actually, even because we have some of those little inconsistencies. However, those don't really matter in the long run because we can just say, okay, yeah, I want the biggest one, and we get most of the object in that. So we can see that for the other one as well. Yellow is shaky, blue is much more defined. Blues are really good for color detection. Next up, we can see that we'll just grab a bounding box, and even though that yellow is shaky, hey, we have a full bounding box right now. We can get the center of that bounding box. We can get any other data we actually need from that bounding box. And it's really simple to do that because rectangles are easy to figure out the center of. There should be methods for that. Honestly, what I would recommend doing is just doing some research on how do I do a image threshold in Java with OpenCV. And it'll show you exactly how to do it. You can get it set up and working really quickly. So we'll do that for the blue. The blue is more defined as usual, just because blues are way easier to find. We'll just move on to the next one. Yeah, so this is one of the weird little scenarios. So I can show you what this image actually looks like. And yeah, this image is a little bit garbled. It's not the best image. I'm applying that same logic as the red and yellow and doing that color thresholding. So in here, we have a really, really jumbled mess. And this is one of the problems with OpenCV and just basic level color thresholding, because we're getting all of these yellows as one bounding box. That's one of the things you have to be careful for, because it's just going to happen no matter if you like it or not. As you can see for the blues, since these blues are a little less blue than this image, it's not going to work the same. So these are just the things you got to be careful of when you're programming these kind of things. But you can see if we have it zoomed in further, a better angle on it, now we're getting better scenarios. These two are still in the same spot. Not that big of a deal. If you really wanted to separate them, you could create some proprietary system that checks the sizes and the shapes and checks if this one's a rectangle and this one is detecting this whole thing, well, there must be two rectangles, something like that. So we're going to see a couple different examples. It's just going to get less and less accurate the more you erode and dilate it. And even right here, yeah, we get this entire side. So this is one of those examples of you got to be careful. And honestly, it's just something you're gonna have to learn in real time, because I can't show you exactly how to fix this, because it's not gonna work for you either. It has to be on your own system. Next up, same thing. You can see it's grabbing this top one now. It's just grabbing a bunch of stuff that it shouldn't be, which ideally we would fix. But that becomes very complicated very quickly, and I did not spend that much time on this repository. Next up, you can see if we erode and dilate it down, do different things with it, we can see that we're getting some really weird bounding boxes. And in this scenario right here, when we're getting a bunch of these weird ones, is I would just say, okay, only take the bounding box if it's bigger than a certain amount of pixels and its area is bigger, because we don't want this small one right here. We don't want these two small ones right here. This one even really is not that usable for us just because it's on the corner. Ideally, this one would be a little bit more tuned, but that's okay. That one's usable. These ones are kind of usable. We would prefer this smaller bounding box right here over this massive one, because if we're going in and trying to grab a sample, we want precision. So these are examples of what you need to be careful of, what you need to fix, just kind of what different ways to do things are. For example, for this one, I used this very heavily in center stage because we had one box here and one box here, and it would be randomized between one of the three. So there were 3 tape marks. We could see 2 of them. So we say, okay, I want the mean average of this box that I'm going to define right here. I want the mean of this one. If it's one of these, cool. If it's neither of those, if it's neither of these two, well, since we can't see the third one, it must be the third one. So that's another way you can kind of manipulate data in your own way. Yeah, you can make these really easy systems that work really well, are really fast, really consistent. I really like the mean of area stuff because it's consistent no matter what lighting. Because I can say, oh yeah, if it's between this red and this red, well, it's red. Super simple there. But yeah, and that's going to conclude this chapter of coding for FTC.